All right, let's talk about a new kind of workforce that's quietly taking over the high stakes world of finance. I mean, these guys are tireless, they're unbelievably fast, and they work 24/7. But they also carry a hidden and, frankly, a potentially catastrophic new kind of risk.
So, who are these new employees? Well, they're not human, they're autonomous, agentic AI systems. And you gotta think of them less like simple tools and more like digital team members, ones who've been given the authority to make critical financial decisions all by themselves around the clock.
And look, they're not just shuffling papers in the back office. No way. They are on the front lines. We're talking about deploying them in workflows like portfolio construction, high frequency market making, and fraud detection. The places where one tiny mistake can have absolutely massive financial consequences. And that brings us to the central, kind of terrifying question, right? The speed and the scale of AI. That's its greatest strength. But what if that strength becomes its greatest weakness? What happens if you get a correlated failure that happens everywhere, all at once? Okay, so let's really unpack this specific danger. It's a risk that regulators are actually starting to give a name to: AI monoculture. And it's a direct threat to the stability of our entire financial system. Think of it like this. Picture an ecosystem with zero biodiversity. If all the trees in a forest are the exact same species, a single disease can just sweep through and wipe out the entire forest in one go. Well, AI monoculture is the digital version of that. A single hidden flaw in a model or a piece of data could infect every single one of your AI agents at the exact same moment. Now, this is where the math gets really, really scary. With independent agents, if one fails, the risk just adds up. 1 plus 1 equals 2. But with a monoculture, the risk doesn't just add, it multiplies. A single error doesn't just create one problem, its impact can literally square with every agent that shares that flaw. You get a cascade that just amplifies exponentially across the whole system. This chart shows something from network science, and it's called a phase transition. The crazy thing is, the risk can stay deceptively low for a while, even as your systems get more and more similar. But once you cross this critical tipping point, and the paper we're looking at says that's a coupling score of about 0.85, the potential for a system-wide failure doesn't just rise, it explodes. So, how in the world do you prevent this kind of catastrophic collapse? Well, there's a proposed solution, and it's this really sophisticated defense system. It's called the Finance-Grade Verifiable Governance Architecture, or FG VGA for short. The way this thing works is by building a layered shield. It's not just one control, it's 5 interconnected safety planes. You've got the policy plane, which is basically the rulebook, an evidence plane, that's like an evidence locker, creating a perfect audit trail, an attestation plane, that's like a constant ID check, a sustainability plane to track resources, and, most importantly, a systemic plane, designed specifically to monitor for that contagion risk we were just talking about. And inside that systemic plane, that's where you find the most innovative idea in this whole framework. It's not just about watching for risk. It's a way to actually measure and score the level of AI groupthink happening in your organization. It's called the Heterogeneity Score, or HS. And you can pretty much just think of it as a diversity score for your AI team. It boils everything down to a single, auditable number that tells you exactly how different your models are from each other, giving you a direct defense against that dangerous monoculture risk. But the score isn't just some simple check. It's actually a pretty sophisticated composite metric. It looks at 3 really key things. 1, how different are the AI's final answers? 2, how different is their internal reasoning, their representation of the problem? And 3, how differently do they react when you just slightly change the input data? You combine all those, and you get a really robust picture of true model diversity. And here's the crucial point. This score has teeth. A low diversity score isn't just some warning light on a dashboard. It's a gate. It automatically triggers real-world consequences, things like a mandatory escalation to senior execs, requirements for higher capital reserves, or even just an outright denial of whatever the AI was proposing to do. So this whole framework, it really represents a powerful new way of thinking about safety in these complex systems. It's a shift in philosophy. You stop trying to predict every possible failure, and you start actively preventing the worst-case outcomes. So how do you do that? How can you possibly guarantee safety when the number of ways a system can fail is practically infinite? The source material uses this fantastic analogy. Think about making e-scooters safe, right? Do you sit there and try to predict every single pothole, every distracted driver, or every pedestrian that someone might run into? Of course not. That's impossible. Instead, you do something much simpler, and frankly, much more powerful. You just limit the maximum speed. This perfectly illustrates a concept called geometric safety. See, in Switzerland, they cap e-scooters at 20 kilometers per hour. Why that number? Because physics tells us that at that speed, the kinetic energy in any crash is generally survivable. You haven't predicted the specific accident, but you've bounded the damage. And the financial equivalent of that is setting hard limits on trading exposure to make sure that any AI failure, no matter how bizarre or unexpected, always stays within the firm's capital reserves. At the end of the day, making all this work in the real world comes down to rigorous, disciplined execution. It means building and actually following a checklist that asks the tough, practical questions. Is there a kill switch? Are we watching our vendor concentration? Do we have an auditable break glass policy for emergencies? This is what finance-grade assurance really looks like in practice. And that really brings us to the core philosophy of this whole approach, and it's summed up perfectly in this quote. The goal isn't to pretend we can eliminate all risk and uncertainty. That's impossible. The goal is to take that uncertainty and convert it into something we can control, something we can provide evidence for, and something we can hold ourselves accountable for at the very highest levels. So this framework provides a really powerful blueprint for finance, for sure, but it leaves us all with a much broader question. As these powerful, autonomous systems start to run more and more of our world, not just in finance, but everywhere, are we building these kinds of essential guardrails fast enough?